In this video, we're going to talk a little bit more detail about the internal rate of return. And basically, the rule is any investment that has an internal rate of return that's greater than the cost of capital is a project that you would accept. Typically, it will give the same answer as net present value, but not in all situations, especially when we have to rank projects. So in general, the internal rate of return works great for standalone projects if all the project's negative cash flows are before the positive cash flows. So why is this important? Again, it's all about technique. It's all about our ability to use a technique for any kind of project that's out there. So again, it's not intuitive as to why this is important. But if you think about the average project you do, you will invest, there'll be a negative cash flow, and that will be followed by a series of positive cash flows. If that type of cash flow stream is not present, if there's something else, then internal rate of return does not work very well. So again, we want to identify when internal rate of return works and when internal rate of return does not work. So the disadvantages to the internal rate of return is, again, it doesn't really distinguish between investing and borrowing. So what this means is it doesn't distinguish between the negative and positive cash flows. This is an issue mathematically, right? It is a quantitative question. What rate of return is created by a particular project? Solving for that formula has challenges if we can't distinguish between investing and borrowing. There may not even be an answer or multiple answers maybe. And again, we've talked about mutually exclusive investments, right? You have to pick between projects. If you have to rank projects, there's an issue. And of course, it's very easy to understand and it's easy to communicate. The issue is these side conflicts and challenges that we have. So again, coming back to our two projects, we've mentioned this earlier. Net present value is higher for B than A, but the internal rate of return is higher for A than it is for B. So the internal rate of return says A is better. We know that project B is better because it has the higher net present value. Again, we've been talking about this concept, mutually exclusive versus independent. We've been bouncing these terms around a little bit. Essentially, independent projects, maybe there's just one project, right? So you can just do this project or not do this project. And there's always some minimum acceptance criteria that goes along with every technique. However, if there's more than one choice, right, then we need to be able to rank the alternatives and select that alternative that is the best of the group. So what technique should you use to do that? Now, the theoretical answer, and we've talked about this a bunch of times, the theoretically correct answer is you use the net present value. Why? Because it measures wealth. It gives us a picture of how the value of the company changes through our value additivity, through our separation theorems, through the law of one price. All of those concepts come together to tell us that net present value is the better of the projects or the techniques that we'll talk about. So what happens when things disagree? What happens if internal rate of return and net present value conflict with each other. So we're going to discuss here over the next several slides when the conflict may actually occur. So the first project we have here, we have project one, it's a delayed investment. So you've just retired as a CEO, publisher's giving you a book deal, right? So they're going to pay you $1 million up front if you write a book about your experiences. You think it'll take you 3 years to write the book. But of course, while you're writing the book, you can't do any speaking engagements or things like that. So that's going to cost you roughly $500,000 a year. So we want you to, your opportunity cost is 10%. And we want to now calculate, in this case, the net present value and internal rate of returns for these projects or for this particular pitfall, which is the delayed investment. So you see, when we create this in the capital budgeting techniques, things are backwards now. And this is only for this one example, right? It says you get $1 million up front, but that's going to cost you $500,000 for the next 3 years. Now, this is still in the right order, right? You have one positive followed by a bunch of negatives. Typically, it's one negative followed by a bunch of positives. So the internal rate of return technique will work, but we have a conflict, right? In this case, the net present value is negative and the internal rate of return is positive, and it's greater than the discount rate that we talked about, the opportunity cost. So would you rather have 23% or 10%? Well, of course, I think you'd rather have 23%. So it sounds like this is a very good project when you're looking at internal rate of return. But let's think about what the net present value number tells you. The net present value tells you that you are actually going to be worse off in value. Your wealth will decline. In this case, it'll decline by $243,000 over this 3-year time frame. So this is, again, a picture and a type of a project, if you will. Certainly these projects come about, but in this particular project, you can see that the internal rate of return does not give us a good answer. If we look at the net present value profile for this project, we can see that it actually looks different. It looks strange that as the discount rate increases, net present value increases. And that really doesn't make sense, as risk and return should follow in the same direction, value should go in the opposite direction. So this gives us an increasing function, which doesn't make sense from an investment perspective. So again, this particular project, right, this delaying of a contract, right, it seems that the internal rate of return is just not the right project or not the right tool. So now let's assume they're going to offer you $550,000 in advance and $1 million in 4 years when the book is published. So now, should we accept the project or not? What does it look like? Well, again, if you look at the data table, and we need to enter the data obviously into the capital budgeting techniques worksheet, what we find is a strange thing. We find that we get a curvilinear function, but it is a curvilinear function that crosses the zero axis twice. It's this cup-shaped curve. Instead of being downward sloping like this, right, it is this cup shape. which tells us that internal rate of return, I don't know that I've mentioned this earlier, but in the net present value profile, the internal rate of return is identified where the curve crosses the zero axis. So in this problem, there are actually two answers. There's multiple IRRs, which we can't have an answer that has similar, if you will, similar types of answers, two answers to the same question. We need one answer. So what happens here is because these cash flows now are different. Remember, we talked about normally you get negative cash flows positive by a bunch of positive cash flows. In the last one, we had a positive followed by a bunch of negative. But in this example, you have a positive cash flow, you have three negative cash flows, and then you have a positive cash flow. So now we've added this strange cash flow stream. And in this case, you have a multiple IRR. So if you see a project where the streams change, and this is not abnormal by any stretch of the imagination. This happens many times in manufacturing when you have very large pieces of equipment that sometimes break down. It might take a very long time to repair them. So in any one year, they could have a negative cash flow through rebuilding. So again, what we have here is internal rate of return is not going to work. Doesn't give us the answer that we need. The other pitfall that we can talk about is if there is a non-existent IRR. So in this case, we do 600,000 and $1 million at the end, and I need a K here, sorry, at the end with these cash flows. So there's no internal rate of return exists. There's no discount rate that's going to get net present value equal to zero. So now we still have this cup-shaped thing, but you notice none of it is down at the zero axis. So there is no internal rate of return answer. There's a net present value answer. That's what this net present value profile tells us. But there is no zero net present value answer regardless of the discount rate. So what do we have? We have these conflicts, right? So the internal rate of return has shortcomings, right? It's still useful, right? It measures the average rate of return of the investment. It gives us a concept of some sensitivity to some estimation error in capital, the cost of structure, right? Cost of capital. So we can analyze the sensitivity of our information. So it gives us information, but because of its unreliability, especially with respect to these three kinds of problems, we have to worry about whether or not it will give us an answer that we can count on. So again, that is the end of this video. I'll chat with you in the next one.